It'll be really, really, really simple. And a lot of times, the requirement of the diagram only will not be there. But sometimes there are places where diagram is required, just like this, for us to make the question much more simpler. Whatever being told, let's read this. Just listen. It says the electric field lines on the left have twice the separation on those to the right as shown in the figure. Okay, figure I'm supposed to talk about. Can you guys see it? The claim is correct, no? That the left have much more wider compared to the right side. Now, what is wider or narrower mean? The other day I told you. Wherever they are together, wherever a kind of cluster is being formed or the distance is less, it means that the electric field is strong there. So if you blindly ask me, see, the question might not be about being strong or being weak. If you blindly ask me, compared to A and B, which point electric field is stronger, the answer is 100% A. 100%. Even though the electric field is going from A to B, I don't care because this cluster is there here. A is towards A only. The electric field will be stronger. Let's keep this in mind. This is my conclusion after statement number one. Now statement number two says if the magnitude of the field at A is 40 Newton, 40 volt per meter. 1 minute. Let me make a note of that. They've given me something, so that's important for me, so I write that. So here the value is given to me as 40. I think I'll use yellow. I am not doing this. The question only tells me that. What is the force on 20 microcoulomb charge kept at P? Now there's a charge. I'll draw a point charge, and that point charge is 20 into 10 to the power minus 6 micro. This is 40 volt per meter. Now, first of all, you won't have come across volt per meter yet. This is a case set question which I chose from. So think from their perspective. According to them, every chapter they might have finished. So volt per meter actually comes in the next chapter called as potential. I didn't want to wait till the next chapter to solve this question because it is out and out of field line. Okay. Now see, this is what we know. What I am supposed to do, this is what is going to be the question. What I'm supposed to do, I'll see. See, if I ask you a question, at A, if it is 40 volt per meter, at P, will it be more than 40 or less than 40? 100% the answer is less than 40. How do I know it? The electric field lines here are much more wider compared to A. So whatever answer I tend to calculate near B, it will be 100% less than 40. Fine. But I think they give me a hint somewhere there. Let me read this. It says electric field lines on the left have twice the separation. Meaning at A is more, B is less. Now, how much more? Double. Which means, don't you think? The electric field lines at a B will be exactly 20? Because it says twice. Now, 100% B had to be lesser compared to A. Why? The thickness here with the width here. So here it will be 20 volt per meter. This is not given to me, but I understood only based on the statement. Okay, this is where common sense and this is where intelligence lies. Now, one slight movement towards the ABCD I'll look at. And first of all, they're asking me what is the force on a random charge kept at P? See, I'm supposed to find the value of F. Till now, to find force, we were supposed to use Coulomb's law. Okay, but Coulomb's law, don't you think was working when there were two charges? Now they're telling what is the force on 20 microcoulomb, which means there's only one charge. So applying Coulomb's law might not make a lot of sense here. So now let's think in the same chapter, did we come across some other formula for F? The answer is a yes. Okay. So remember, E is equal to F by Q we learned. E is equal to F by Q. If you crisscross, F will be equal to Q into E. F will be equal to Q into A. Now, why am I doing this? Because if you look at this formula, only one charge is there. And that charge's value I know in the question. Okay. And moreover, understand here, guys. What is the force on 20 microcoulomb charge kept at B? They had not told me what is the electric field at B. I found it using my common sense and one statement and the first statement. So F is equal to QE. I'll write F as it is. 20 as it is. Micro is 10 to the power minus 6. At A it was 40, but they're asking about B. At B it will be less than it because width is there. 20. How 20? I told you. 20. Okay, so now what? 20 into 20 gives you 400. 400 meaning automatically I got my answer. No, 10 to the power minus 6. So much calculation is not required. The answer is A. I would see 2 and 2 and then tick 4 and come off. I wouldn't even think twice. Okay. So automatically electric field at A is more compared to electric field at B. Open bracket and write the reason. Less width means less width means stronger electric field. Stronger electric field. Got it? Now, how exactly 20? The question said. The question said twice. That's why it comes into you. Okay. And second statement, right? Second statement. To find force. To find force without using Coulomb's law. Without Coulomb's law. Right? F equals Q into E. You will know this, but at that point of time, it should hit your brain. And I want you guys to understand one more thing. Never ever judge a question based on the diagram. Okay? People automatically see if you're judging a question and think it is easy, I would 100% recommend that. Okay? I would 100% encourage that, in fact. But if you tell me that, okay, sir, diagram questions are kind of off. See, I used to believe that shit. Okay, until you guys understand it. So here, if you think from a noob's perspective, the question is here. If I scroll, it's of 5 lines. I understand that it'll take more amount of time for me to get the answer. Okay, that doesn't mean you skip the question. And moreover, there's a diagram. And moreover, if you look at all the four options, there 10 to the power, 10 to the power, 10 to the power, whatever is there. So every part it is confusing. But if you see, I got the answer within no time only by understanding one small concept of analyzing the diagram. Okay. Most important this is. Graph questions, these questions, it's like a mirage. Okay. It's like a mirage. It only seems to be difficult, but in reality, it is not. You will be able to answer it very simple. See, full such a big question. What's the formula being used? F is equal to Q into E. We are not even using Coulomb's law. Understand? That's how the depth is. Okay. I hope there's no doubt in this question. Correct? If you're still thinking why 20 here, one last time I'll repeat that. Look at this. It says twice. It says the electric field on the lines on the left have twice the separation. Twice the separation meaning whatever value on the right side it was there, half of it. Because twice becomes 1 by 2 no, once it gets shifted. That's all. That logic I'm trying to use. So yeah, this is the end of the first question today. Next question. This will come little later, man. This is not such an important question. Okay, I wrote it because I copied it from your previous year question paper only. This is there, not that important. Okay, so right now I'll skip this. This is important. An electric dipole important. Wait, I get excited the moment I look at the word electric dipole. Is kept in non-uniform electric field. Very important. Now listen. The other day we spoke about uniform electric field. If it doesn't ring a bell, I'll repeat it. Remember, we drew on something. We drew a diagram like this, and the answer for this was tau equals PE sine theta. Is what I told you the other day. I told you when an electric dipole is placed in a uniform electric field, what happens? It starts rotating like this. That's what I told you. Okay. And I also, immediately after this, I also give an example. So let's say if it is non-uniform, somewhat like this. Okay. Here, if you see, this is non-uniform, no? Because here it is more compared to the outside part. So in this case, what happens? I also told you the other day, it'll rotate. But along with the rotation, it'll move. Remember the other day I told you? So there is something called as translation happening, translatory motion. Okay. It is moving in a specific path. When it is moving, it is also rotating. So actually, if it is non-uniform, what we expect is nothing to happen, but in fact, two different motions are being projected there. One is something called as translatory motion, where the actual dipole starts moving from left to right while rotating. Okay, the other day I gave an example of a wheel. The wheel, if it starts rotating in one place, that is called as uniform motion. Okay, if the wheel starts rotating and starts moving from point A to point B, that means it is following translatory motion and rotatory motion at the same time. So if it is non-uniform, it means non-uniform two motions, uniform one motion, and both. Okay, this is the concept. Okay, I repeated the concept. Done. It generally experiences, my handwriting is superb, I know. This is called generally. It generally experiences what? Guys, now listen. Read both. I mean, read all the four options because I can see the word torque and force being repeated so many times. Okay, torque and force being repeated so many times. So you will have to. It says first option says it says a torque but not a force. Guys, understand? If it is only torque, it means uniform. Correct. So the option A is wrong. A torque but not a force in the sense it is also moving, which means some kind of force has to be there. Option B says a force and a torque. Option C says skim. Option C says neither a force nor a torque. Guys, common sense, something is being felt. So C also can't be an option. A force but not a torque. See, understand. This also is incorrect because just now I told you it is experiencing what? It is experiencing a force. Because of that force only, it is moving forward. Okay, that's called translatory motion. Rotatory motion because it is experiencing a torque. So the actual option is B. Fine. So electric dipole, uniform motion. Okay, let's say, guys, let's say the question, I'll change it. Okay. Let's say if they only say uniform motion, then what's the answer? Then option A would have been the answer. Why? Because it only experiences torque but not force. But the moment I place it in a non-uniform electric field, it means it undergoes a force and a torque, both of them. Okay. So you go back to your books, you will write uniform electric field. Guys, 1 minute. Make sure you write this, okay? Dipole placed in. That is the most important thing. You just can't keep writing shit. Dipole placed in. Dipole placed in. I hope you guys are making a note of all these things in your CET book. Dipole placed in uniform electric field. Put a hyphen. Put a hyphen. Experiences only a torque. That word only is important. Experiences only a torque. Okay. Next line. Dipole kept in non-uniform electric field. Dipole placed in non-uniform electric field experiences force and torque. Right? Two motions. Example wheel. Okay, example wheel. What happens to the wheel? It moves forward. Um, it moves forward and it is rotating. You know what is in a uniform electric field? Just imagine the wheel got stuck in some random pothole. Now the reason I'm using that pothole because it's raining and it's these are very common scenes in Bangalore currently. So now what happens if a wheel gets stuck? No, what happens in a pothole? It keeps spinning there itself. It's called as wheel spin. They keep telling. So here the wheel is spinning, which means torque has been applied. Is it moving forward? Not moving forward. So in that case, that will be called as uniform electric field. Correct? So if you see this is an out and out theory question, this is exactly how your chemistry question paper will be set. This I'm not sure as to which year it was been asked as case set, but it was asked. Fine. So there are, if you see here, case set problems are not difficult, but these people, they started off again. Mm, mm, mm. Okay, done with this. Next, cool. Listen, the magnitude of a point charge due to which electric field 30 centimeters away has the magnitude 2 nano, I mean 2 NC, 2 Newton per Coulomb will be what? Okay, first of all, you need to understand the question. The magnitude of point charge due to which electric field 30 centimeter away has the magnitude. Okay, now in simple language, guys, ignore all these things. Okay, electric field. What's the what do you call unitel? Newton per coulomb. So electric field in this question is given to me. See, sometimes okay, the way they write the question is so hi-fi there, right? You think it'll be like on J question, but in simple shade it is like one regular question only. What I'm supposed to find? The magnitude of the point. Okay, point charge. Okay, fine. Q is supposed to find. I magnitude of point charge meaning Q is question mark. Hmm. 30 centimeter away will obviously be distance. So R equals 30 centimeter. 30 into 10 to the power minus 2 I'll write off. Why tell? Because centimeters is in not in SI units, but this is SI units. So I have to convert it. So after converting, it becomes R equals 30 into 10 to the power minus 2. Correct? Now listen. No. I'll tell you one small thing here. People think I'm. Oh, I feel like laughing, bro, actually. Some chaps are there, half baked potatoes. Anyways, this is on Monday. Rajit, I know you're very happy, da. I think more than you being happy, Dheeraj will be, I think, jumping over the top of his bed right now. You think? uh, best. Yeah, I know that. One second, one second. Yeah. Anyways, guys, E is given to me. R is also given to me. Q is question mark. How do you find array regular formula? E equals. Now I'm gonna waste time by writing the formula. We are right. We are trying to solve K set questions. You should not. Okay, I'm gonna waste time. Into Q by R square. Q by R square. Okay. Now see how I'll skip. I'll write 2 equals this 9 into 10 to the power plus 9 into Q. Don't know. 30 square. 30 into 30 you write into 10 to the power minus 4. Directly I do off. Now so don't sit and do 30 square and waste time there. Okay. I hope you guys understand it. Yeah. Uh, Next, see what and all can get cancelled. 10 to the power minus 4. Okay, Q is here. That's important. So right now 3 times 3, 3 times 3 got cancelled. Now in the denominator, 10 to the power 2 zeros and 1 become minus 2 guys basically. Okay, the minus 2 goes on top becomes plus 2. So the answer is, see, guys, understand? Three got cancelled with three. Okay, sorry, nine got cancelled with three and three. Nine got cancelled with three and three. Only two is remaining. I can see after two being remained, everything else, whatever is there, is only in 10 powers. So what do I do? Two into 10 to the power minus 7 directly take off. Got it. Obviously, you should not be in a state to write. See, will you sit and write data like this? I would not do it. I am explaining it. That's why I'm trying to do write data. If you see, this is a typical way of how we're solving a PUC question, but that's not how it should be. You should understand. Okay, magnitude of point charge in simple language meaning I'm supposed to find the value of Q. R is given to me. One thing. See, this is where intelligence comes into picture. Centimeter is not SI units, so automatically convert that in terms of SI units. Then obviously electric field is there, and then electric field's formula supposed to understand. This I would write. This I would write if you are feeling not if you're not feeling confident. But if you're feeling confident, I think that also you guys can skip it. So two will be there, and 1 second, please. 1 minute. The screen thing. I think you would have stopped sharing now. 1 second. 1 second, guys. Yeah, yeah, yeah. Cool. Yeah, no, no, no. That thing won't come. No worries. Yes, yeah, I'll do that. I'll only send the PDF, but the answer obviously won't be there. Anyways, okay. Yeah, okay, this is the thing is, so automatically the moment I wait till cancelling of the 9, once it gets cancelled, now automatically I'll keep doing my stuff. I just multiply 2 into 10 to the power minus 11 is my answer. That's how it is. So what should you write here? Nothing. But one small tip here is you'll have to avoid all writing this date and all. We're not trying to solve a PUC question. Any other doubt here? No? Lovely. Cool. Go to the next question. Next question. Ah, now, see, till today I have this trauma, okay, that whenever I look at these electron kind of questions, I literally kind of get excited. Telling, see, again, this is also more like a mindset game. 10 to the power 10 and all is there, no? But, anyways, take it lightly. We'll solve. It says some amount of electrons are removed from a neutral sphere. Let's think from a perspective where neutral meaning equal number of positive, equal number of negative are there. Now, the moment you take off electrons meaning negative charge, if you take off all the negativity from a neutral thing, it obviously becomes more positive. Now, if you ask me, sir, how much positive, that depends on how many ever negative charges you're taking it off. For example, let's say you take off 2 negative charges. It means it became 2 positive. Okay. If you take off 10 positive, 10 negative charges, it becomes 10 positive. Here we are taking off so many negative charges. So it becomes so many positive, so much positive. So how many ever electrons were taken off? The same number of electrons, will become positive. Okay, so that is the value of Q here. That's the value of Q. Getting it? I am not by hearting this. You just see if they say 4 electrons are removed, it means 4 plus. 4 plus is the answer. So now they're removing how many electrons, so it becomes so much as a but in a positive sense. Fine. Metal sphere of diameter 20 centimeters. Again, centimeters, I don't like it, so you'll have to convert in terms of meters. All those things will do. Is placed in air. I only couldn't read this. AIR, air it is. The magnitude of electric field, Newton per coulomb, which means everything should be SI. At a distance, whatever, this is again R. From its center is. So in simple language, asking me to find the value of E. E is given by the formula. Okay, what is that? Just now we learned, no, 1 by 4 pi epsilon naught. See, instead of writing the formula, what I'll do this time, I'll write off the value directly. I anyways know the answer, no. 9 into 10 to the power 9. Okay, into Q. Do we know the value of Q? Yeah, we know it. But it is electrons. Now understand. Somewhere when I taught you guys a concept called as quantization, I would have given you a formula. Q is equal to N into E, where Q is the total number of charges, N is the number of electrons or protons, whatever, E is the charge on each electron. This question is supposed to use this formula of Q equals N into E. If you ask me why, look at this. I am not removing charges. I am removing the total number of electrons. You might obviously ask me, sir, then why write Q here? Using that only I'll be finding Q. Okay, so this is the number of electrons being removed. To find Q, you will write that number of electrons and multiply this with the charge on each electron given by the, what's the number of that? We know that 1.6 into 10 to the power minus 19 coulomb. Charge on each electron we tell, no? So this is the Q is equal to N into E. So what did I do? Electric field is given by the formula 1 by 4 pi epsilon naught, okay, into Q by R square. Q was given by the formula Q into NE because electrons were there. Whole thing divided by R square. R is how much? 20 centimeters. So you write 20 into 20 into 10 to the power minus 4 directly you write off. Why? Because just now I told you minus 4 in the sense what happens? That minus 2 it has to be because of meters. You'll have to square that and it becomes of minus 4. So if you solve this, you'll be able to get the answer. Now see how to solve. Listen. Ignore the 10 powers. Why? I am not ignoring because I'm too smart or something. I'm ignoring that because look at all the options. It does not have 10 powers, which means even I should not care about 10 powers. Okay, if it by chance said 640 into 10 to the power something, that is when I'll think over it. But right now, none of my options have 10 powers. So sitting and wasting time on 10. Now, if I did the same thing with the previous question, you should obviously question me. But in the previous question, the 10 powers were required. Therefore, I spoke about this. Here, not at all required. Ignore it. Okay, ignore it. Now see, ignore 10 powers meaning ignore all those zeros. Ignore off. Now, 2 gets cancelled with 4. 4 went off. 9 into 1.6, bro. 16 into 9 is 144. D is the answer. Okay, now don't ask me, sir, how is it 1440? Array, obviously, no. 16 into 9 is 144. Is there any other option near it? No. So the answer will be 1440. Will you sit and cross check? You should not. Will you cross check? 10 power is not there. So which means I'm correct. So just keep doing it. That's all. One place to remember here is wherever electrons are being removed, okay, that is not your direct answer for charge. You're supposed to use Q is equal to E. So go to your notebook, right? If if the question if the question is in terms of electrons, is in terms of electrons, then use Q equals Ne to find the complete charge or the total charge. Then use Q equals Ne to find the total charge. Okay. And both, I think you got confused, yeah.
No, sir, she clearly told quantization means adding up all the charges.
She didn't tell additivity for that.
No, she didn't speak about that only.
No, additivity is adding up charges. Quantization is nice, yeah. What else will I react to, bro? Anyways, just write that, guys. Funny fellows. Okay, done with this. I won't tell it's an important question, but it's a nice question. Nice or not nice, it's a CET question. Okay, that's why. Next, clear. Oh, iPad went off. Next question. This also. Look at this. This actually. I like this question. Superb. The question is okay. It first time when I read this question, it went over my head until I read it again. Let's say, see, guys, please focus here. Important question. Um, More than important in the sense, this is the type of questions that a lot of people will not score. You should score. That gives an advantage. Now listen, 3-point charges of plus 2, minus 2 and minus 4 are placed at ABC of an equilateral triangle of side X. So this is the first sentence. One sample diagram I'll draw. Okay, A, B and C. At B, I'll place plus 2Q. At C, I'll place minus 2Q. At A, wantedly only I'll place plus 4. Now, this is the actual diagram. There'll be X here, X here, X here. This is the meaning of the first sentence. Now, they're telling the magnitude of the electric dipole moment. Dipole moment. Remember the other day we used something called as P. P equals Q into 2A is what we learned the other day. So I'm supposed to follow that. Find that, sorry. P equals Q into 2A. I'm supposed to use and find. Okay. But you know what's the crazier part here? Why people won't get the answer? Electric dipole moment of the system is what they're trying to ask you. Now understand, B is plus 2Q. It is trying to form a dipole like this. One dipole, one more dipole. But it does not happen. Why? Because there's only one A. I'll repeat that. So now what happens here is, actually what they're telling us indirectly is, at A, there are two charges, namely minus 2Q and minus 2Q. If you combine both of them, it is only plus, it is minus 4q, correct? Look at this, minus 4q is given to me. But at A, what's happening here is, because they're telling I'm supposed to find dipole, this minus 4 will sacrifice itself. This is by default, okay? The minus 4 will sacrifice itself and try to play as a team player. So it will be like, Erebus, I'm minus 4. I will give 1, 2 to the first B. I will give the other 2 to C. So A will participate in both AB and AC after getting divided. Now, why is this happening? Because AB's direction will be like this. AC's direction will be like this. Now, the other day only I told you, when there is electric field or whatever, or force, whatever, in two different directions, then the resultant will always pass through the center like this. This is my resultant, correct? So, similarly, from AB, one force is going, one field is going. From AC, one more field is going. Where do you think the resultant will pass through? It will pass through exactly through the center like this. This is the concept. Okay. Now, if you understood this, automatically you'll be able to get the answer. So, is this explained anywhere else? It won't be explained. I'm telling you that also. Fine. So, the dipole moment of AB is what? P square, just P. Here also it will be P because same charges. No, that's why. Now, what's the resultant here? So, one second, wait. I think wrong place I drew off the diagram. It is consuming too much amount of space. This is field 1, field 2, electric field to the center. Wherever it is happening like this, how do you find the resultant? Is equal to root of A square plus B square plus 2 into AB cos theta. Now listen, it is equilateral triangle, meaning theta will be equal to 60 degrees. Cos 60 is 1 by 2. This 1 by 2 gets cancelled with 2 and 2. Now all these values will be same only. Why? 2, 2, 2 and 2. All of them 2, 2, 2 is there. So R will actually become root of P square plus P square. A also it is P, B also it is P. Therefore it gives you again P square. So the answer becomes root of 3P square. The P comes outside. The answer becomes root 3P. Now listen. Understood how it works? So it sacrificed, became two parts. The first dipole will give you answer as P. Second dipole will also give you answer as P. Now don't ask me, sir, how P? Array, 2 into A into Q is what? Now, A in the sense is the dipole distance. Take off A, put X there. Same only it will be 2 into Q into X. This will be answer as P. This also will be into P only. Instead of A, use X there because it's given to us in the question. So 2QX is what? P. Instead of A, put X here. Again, it's P, no? So P here, P here. That's all. I do the math. So the answer is coming to be root 3P. Obviously, none of the options are matching. Not required. What's the value of P? P is just now is found. P is equal to Q into 2x. So it becomes root 3 into Q into 2x. So A. 2 root 3 QX is the answer. Same. You just put the 2 before. Important question. Correct? So what do we do? One thing, sacrifices from minus q, minus 4q. Splits up to form minus 2q, minus 2q. Both of them form P, Done, X was given to me. Now, when two fields are going in two different directions, the resultant is always through the center that you guys already know. So resultant formula, the other day we spoke about this, we get the answer, we end up getting root 3p. But unfortunately, root 3p is not the direct answer. So we'll go one step ahead and try to find the value of p, q into 2x, we get the answer. Important. Now, is it widely asked? No. There will be 1 year, okay. So I think 2017, this is 2017, they would have chosen physics to be, they would have chosen the questions from physics should be harder. This is the so-called hardened KSET. Fine. Now, obviously, you'll ask me, sir, how should we get to know that it will sacrifice? Again, that's the whole point of a charge. Okay. Charge and energy. Okay. You will never know when it will help and it will sacrifice. You'll have to be prepared for it. That getting prepared only is common sense is now don't get scared. Okay. Like for example, these kind of questions is not the first time being asked. No. So if you practice these kind of questions, these sacrifice kind of questions, the reason I chose this is because you should know that this also is possible. So next time when I use the word sacrifice in electric field, you should not get, you should not feel new to that. That's the whole point. But is this very, very, very important in terms of CET? No. But will it be asked? Sometimes, yes. It has been asked. Cool. Update. Who's this? Okay, done. Next question will go. Little shabby is this. I don't know what to write in this because it's all common sense only. Too much common sense combined together only is this thing. But dipole moment, don't get confused. They're talking about P. See, that's the intelligent part. At that point of time, oh, again, this question. Bro, sometimes they ask this question, I feel like throwing the book, bro. Like, it is not that. People keep calling this, so you don't understand. Ah, fine. So, what is it's is not that important, guys. You just keep it. But this is a lovely question. This is my favorite question. Okay, I don't know which exact year this is, but lovely question. I also feel that will be asked in this. Okay, guys, listen. This kind of question. Let me promise you one thing. Either your CET question or your PUC MCQ. 100% it will be asked. E axial and E equatorial. Open your other book and you see. We did both the derivations, correct? We would have got one of the answers with respect to E axial, and I hope you guys remember that two derivations we did and all these things. Where one answer we get using P, the other answer we might have got as 2P. Now, what people usually do is okay, this and this, both of them will not be equal. Axial is always equal to twice the equatorial. That's fine. So the confusion is between C and D. 99% of the people will always tick D. The answer is wrong. The answer is C. Why? Because it is double. Two is there, fine. Always remember axial and equatorial, both of them, the answer will be in two opposite directions. Very important. So if you go and you look at your books also, okay, axial, the answer might be going towards your right. Equatorial, where we draw the triangle, the answer might be going towards your left. This is a very small thing, but people ignore it. See, the answer is P and 2P. Twice, I know. Absolutely no doubt in that. People think the answer should be minus 2P. It is not like that because we're talking about vectors. If you see how smart these people are, all the four options, they have not missed the vector symbol, which means they're telling it's a vector. Wherever vector is there, direction has to be spoken into picture. So since it is a vector, here automatically minus does not mean literally minus, it means directions. So understand, if axial is going towards your right, equatorial will always go towards the left. So 99.9 people will tick D, which is wrong, even though it is 2. The answer is C, because it is minus 2. Minus represents the direction. So in the next line, directly copy this. E axial will be equal to minus 2 of E to equatorial. This derivation will come from PUC, will come from PUC. This exactly will be asked for your CET, or it will be asked as your MCQ of PUC. Correct? Huh? Next. See, this is where I like this is a superb question. And one more chemistry type of question this is. Pick the incorrect statement. Usually this won't be asked in physics, but again, this is a question. More kind of questions like this only will be in chemistry. Pick the incorrect statement. Incorrect, guys. Electric field lines are closed loops. This is the incorrect statement. It can never be closed loops. Fine? It can never be closed loops. Understand? Um, Magnetic field lines can be. That's the small thing. Okay, now you'll think, hey sir, what simple thing? But just imagine in CET when you're learning so many chapters, at that moment of time you might not, this might not click. So write this also. This is very obvious also. Not like very like it's not like one crazy founding thing, but it's obvious, right? Copy the same thing. Electric field lines are closed loops is incorrect. But don't copy this off only without writing it's incorrect. Then what's the whole point? Is incorrect, you should write. Or you write electric field lines do not form closed loops. Whatever. But make sure you guys write it properly. Then you're learning it and there they'll tell find the incorrect statement and then you'll tick that and come off like one crazy boys means it'll be awkward. Then with this, last question. The angle between dipole moment P, and E at any point on an equatorial plane. Now don't get confused. Now don't tell sir equatorial plane we did for something else. Array, nothing else, bro. Listen. Equatorial plane is always a triangle where the dipole is placed in the denominator. So denominator I'm telling you, base. So here minus q will be there, plus q will be there. Now automatically here it is going, electric field is going in this direction. And when we solved this, the answer was going in this direction. This is exactly what I told you for that minus 2q thing. That's exactly what I told you. So it is going towards your right here, electric field. Here it is going towards your left, which means both of them are going quite literally opposite to each other. Opposite is what? 180 degrees. This is 180, okay? 180 degrees. So opposite in terms of math is 180 degrees. Therefore, the answer is D. So the previous question here, which one is this? This question, that actual question, if asked in terms of angles, this will be the angle. Got it? Should you write this? Not required. I think it's obvious. Now, I have not drawn the full diagram. This is the resultant answer. This is the resultant answer. Okay? Resultant, I'm checking with that minus q to the plus q. Now, if you ask me, sir, why only you're going towards positive? Array, it's always from negative to positive only. Always. Fine. So towards plus q it's going, done. So resultant will go there. You check the resultant. So the diagram, it look like this. One here, it will be going, and the resultant will come like this. Quite opposite to the answer. Therefore, 180 degrees. Opposite meaning, understand? Okay, now if by chance, let's say same. Let's say you get one more question where electric field and both of them are going in the same direction. Then what will be the angle? 0 degrees. Same meaning parallel. Parallel meaning 0 degrees. Getting it? It can 100% never be 90 or 45. This answer will be for same, 180 will be for opposite. So write that in your books. Opposite meaning 180 degrees, same meaning 0 degrees. Now that specific sentence will not be useful only for this chapter, it will be used for multiple different chapters. We are done with the CET part of, I am done doing the CET previous year questions. Okay. Now, the reason I started directly with this is because to make you understand, this is the standard of KSET. Okay, this is the standard of KSET. Oh my gosh. Which means it is only based on your practice. Skill in the sense, skill is required only to become faster. Apart from that, it's peaceful. Got it? Fine. That's it. Go sleep. Tomorrow's class will do something with chemistry. You see, this was interesting part. I didn't want to skip this. That's why. Correct. Okay. Bye.